Good day. Today we'll continue with our lessons on math modeling and I will explore another example, one that I gave nung huling video, which is we'll try to use math modeling to answer the question, can a creature like King Kong exist? So the latest movie dun sa King Kong or sa Godzilla na franchise lumabas nitong 2021 and it pitted these two monsters again. And if you're not familiar, actually, these two monsters go a long way back. Mula nung lumabas si Godzilla from the waters of Tokyo Bay at nung dinala si King Kong sa New York City para umakyat ng Empire State Building. Siyempre, they tried to make a crossover movie. And meron ng crossover movie. Nito palang, I think this would be the 60s. And I think there's another movie na Kong versus Godzilla before this current 2021 iteration. And yet, despite that, let's try to answer the question na in this universe, in our universe, following the laws of physics in our universe, pwede mo mag-exist si King Kong or si Godzilla as they are presented sa movies. This is the process that we followed in our last video, and we'll start by describing the real-world problem. Let's determine if King Kong can actually exist. Step 2 will specify the mathematical problem. So yung ating real-world problem na gusto nating i-determine if King Kong can exist, itatry nating i-narrow yung criteria natin for determining if indeed King Kong can or cannot exist. And for this example, what we'll do is we'll compare an aspect of a creature na kasing laki ni King Kong with siguro yung comparable animal niya sa real world natin ngayon. And that, of course, that would be a gorilla. Then we'll formulate our math model and we'll first make some assumptions. And siguro, yung first assumption natin is yung model na gagawin natin for this problem, ang focus natin ay yung physical dimensions ni King Kong. Kasi there are many aspects that we could look at to determine if King Kong can exist. So pwede nating tignan yung how fast nagta-travel yung signals from the brain to the muscles. Pwede nating tignan kung paano mag-circulate yung dugo sa isang creature na kasing laki ni King Kong. Pwede nating tignan kung kano kadaming pagkain yung kailangan niyang kainin. At paano i-convert yun to energy para makagalaw si King Kong ng isang buong araw, much less makipag-away sa isa pang creature na kasing laki niya. But i-ignore muna natin yung factors na yun. At ang focus lang natin ay yung physical dimensions ni King Kong. And since we'll focus on the physical dimension, we'll also make an assumption na yung body density niya comparable sa apes. So, meaning hindi sobrang laki ni King Kong pero sobrang gaan niya. Dapat yung scaling from the body mass and essentially body density ng isang gorilla, pagdating natin kay King Kong, similar pa rin. So, I think those are fair assumptions but we need to state them para magkaroon ng limitations yung model natin. Then, since we stated those assumptions, baka medyo magiging mas specific yung description natin ng real-world problem. Remember, this model is iterative. Pwede kang lumabas at bumalik sa ibang steps. You don't have to strictly follow yung steps 1 to 7. So, we'll go back to step 1 and we'll rephrase our description. So, can a creature as large as King Kong support its own weight? So, tied pa rin siya dun sa question natin na can he exist or not? But now we're making it more specific. And the mathematical problem na nagko-correspond dun sa narrower description na yun ng real-world problem natin ay what we'd do is we'd want to compare the estimated mass of King Kong with a typical gorilla and how the capacity of their bones to support their weights would be compared. Kasi baka hindi na kaya, essentially, kaya ba nung buto ni King Kong buhatin yung isang creature na kasing bigat ni King Kong? And we move on to step 3, which is we formulate the math model. And we'll use the model na ang mass ni King Kong, it's just some constant na imumultiply sa mass ng isang gorilla. Now, we'll have to find kung ano yung constant na yun, na n. And yung bone strength ni King Kong, it's just another factor which we'll call m na imumultiply sa bone strength ng isang gorilla. And we'll compare kung malaki ba yung pagkakaiba nitong dalawa. So I'll move on to the next page, but yun pa rin yung jumping off point natin na ang mass ni King Kong, it's some constant times yung mass ng gorilla at yung bone strength ni King Kong na kailangan, it's some constant na i-multiply sa bone strength ng isang gorilla. So let's solve the mathematics. Ito na yung involved siguro na step. So una, kano ba katangkad si King Kong? So ginugol ko siya, how tall is Kong in the year 2021? And it's 335 feet. So actually, iba-iba pala yung height ni King Kong sa iba-ibang movies niya. At ito yung pinakamalaking version ni King Kong so far. So it's 335 feet. Let's put that data in our box. Kano naman kalaki ang isang typical na gorilla? So i-google natin yun. Assume natin nakatayo, hindi yung naka-crouch, naka-apak yung kamay sa ground. So it's around 1.25 to 1.8 meters. But since we are using feet dun sa height ni King Kong, convert na natin yung say 1.8 meters to feet. That's around 6 feet. Kano naman kabigat ang isang gorilla? Kasi wala yata tayong data kung kano kabigat si King Kong. Depende sa location ng gorilla. Iba-iba yung weights nila or masses nila. But siguro between yung silverback na western gorilla tapos yung picture ng gorilla sa baba, mukhang mas malapit si King Kong dun sa eastern gorilla. So, yun yung gamitin nating mass niya, 150 kilograms. So, based dun sa height ni King Kong at sa height ng isang gorilla, we can determine na ang scaling factor, kung isang dimension lang titignan, which is yung height, is just the quotient of 335 over 6. So, it's around 55.83, pero hindi naman tayo very exact sa model na to. Let's just set a value of k na 55. Pwede nga siguro 50, pwede rin 60. But 55 should be more or less fine for our purposes. Then let's determine paano natin sa scale yung mass ni King Kong. Kung ang scaling ng height niya from an average gorilla is 55. So what I would do is i-model ko si King Kong as a bunch of bricks na katawan at kamay. Although hindi naman to necessarily kailangan, but just to help us get an idea. Tapos yung height ng gorilla is to scale to King Kong and multiply it by k. Now, each brick would have a volume that will be based on its height, length, and width. Then si King Kong, kung mag-scale ng k yung height niya, then all the dimensions will be scaled by k. So we have kh, kl, and kw for its height, length, and width respectively. The volume of yung original natin na brick will be height times length times width. And yung volume nung scaled up natin na rectangular brick would be kh times kl times kw, which would be rearranging the factors k cubed times h times l times w, or k cubed times the volume of the first rectangle. Now, just to be clear, hindi lang sa rectangular prisms nag-hold yung ganitong scaling factor na pag nag-scale ako ng length ng k, nag-scale ako sa lahat ng dimensions ng k, k cube yung scaling ng volume. This will apply for essentially all shapes. You could try it sa dimensions ng triangle na gagawing pyramid or sa dimensions ng circle na gagawing sphere. If you scale a single dimension by k, the volume scaling is k cubed. And since we made the assumption that the density of Godzilla and a gorilla will be the same, that means yung mass ni gorilla at yung mass ni King Kong, ang scaling factor din natin ay k cube. So, ang scaling ng weight or mass ni King Kong is k cube, and 50k is 55. So, 55 cube is 166,375. If you want to round it off to 160,000, that's fine. So, using this factor, we'll have an estimate ng timbang ni King Kong na 166,375 times 150, which is yung mass ng isang gorilla in kilograms. And we would estimate King Kong to have a mass or weight of, sabihin na natin, 25 million kilograms. Now, tignan natin yung bones ni King Kong. Let's consider bone strength. Ang strength ng bone, well, dependent siya sa several factors, including yung bone density, bone composition, saan siya gawa, yung shape niya. But if we assume na cylindrical yung leg bones, pareho lang naman sigurong cylindrical si gorilla at si King Kong. So, another factor na magbabago pag nilakihan natin si Godzilla ay yung cross-sectional area ng buto. Ano yun? So, let's say I have this cutaway ng isang bone and kunyari bilog siya. Yung cross-sectional area niya, yung area sa taas, it's pi r squared kung r yung radius. Kung pupunta tayo kay King Kong at magsiscale tayo ng isang dimension by k. So, ang bagong radius nung bone niya ay kr, ang cross-sectional area nung bone ni King Kong will be approximately pi times yung bagong radius, kr squared, or k squared pi r squared, or k squared times yung cross-sectional area ni A1. So, ang factor ng paglaki ng cross-sectional area, and we'll use that to approximate the bone strength, will be k squared. So, based dun sa scaling ng bone strength from a gorilla to King Kong, that will be k squared times yung original na kung anumang bone strength ni gorilla. So, that's 3,025 times the original. Now, based dun sa na-compute natin, na-estimate natin na weight ni King Kong, how much more na strength yung kakailanganin niya? E di syempre dun sa scaling nung weight niya. King Kong's bones will require their strength to be k cube times yung original na bone strength niya, or 166,000 times the original bone strength. And ang na-compute natin ay 3,000 times lang. Now, it turns out, mababali yung buto mo if it is forced to support a weight that is 10 times your current weight right now. Nakatayo ka lang. And from 3,025 to 166,375, that's more than 10 times. In fact, it's 55 times or k times. So we could interpret this result na yung estimated bone strength ni King Kong based dun sa scaling niya at sa scaling ng cross-sectional areas ng buto niya will be insufficient para isupport yung estimated weight niya. So looking only at yung magiging bigat ni King Kong at magiging lakas ng mga bones niya, we could interpret it as King Kong cannot exist as he is portrayed in the latest movie. So our next step is we'll evaluate our model. And in the absence of a King Kong in the real world, we could siguro take a look. Ano ba yung currently pinakamalaking land animal? And that would be an elephant. Specifically, the African elephant. And an African elephant has a mass of around 6,000 kilograms. Ginugol ko naman yun. Hindi ko siya hinuhulaan lang. Which is much, much less than yung na-compute nating mass ni King Kong na 25 million kilograms. So, wala na tayong hayop na lumaki pa beyond 6,000 kilograms sa lupa. Kung expand natin at isama natin mga hayop sa dagat, then we'll have the Antarctic blue whale as our largest animal. May daya na yun kasi hindi niya sinusupport yung weight niya sa lupa. May too big to help support its weight. And even the Antarctic blue whale, its mass is around 160,000 kilograms. Hindi siya pumalo ng 200,000, much less 1 million kilograms. So, we don't have an animal, a land animal, na lumalampas ng 6,000 kilograms. And we don't even have an animal kahit na aquatic na pumapalo ng 200,000 kilograms. And you could say naman, nag-exist naman yung dinosaurs nun. So, that's a good counterpoint. Pero, ano ba yung size din ng pinakamalaking dinosaur? Hindi ko yun na-google. So, maybe that's something that you can do. In any case, it seems that yung weight ni King Kong would be far, far too much para mag-exist sa mundo natin. And we could say that, more or less, that is a rough evaluation of our model. And the last step would be to report the solution. Now, paano natin siya re-report? One way to do that would be to write an internet article about it. There's actually an existing article sa Wired about na siguro part na rin ng publicity ng movie na si Godzilla at King Kong. Papasaba sila sa laws of physics natin. And in fact, ginawa ko yung lesson before ko nakita to. So, ang galing na may nakaisip na gumawa nito. But they would actually, if you scroll down the article, they'd actually arrive at the same conclusion that yung bones ni Godzilla or ni King Kong for their sizes, hindi nila makikerry yung mga timbang nila nang hindi madudurog yung mga buto nila pag naglakad-lakad sila sa city streets. Although what's nice about this article is it takes a look at other models that you can do if you make other assumptions. So like tumingin siya sa adaptation ng cold-blooded and warm-blooded animals. Tumingin din siya sa cell growth at sa tissue growth ng mga dalawang hayop. So tayo, nilimit natin sarili natin dun lang sa dimension na sizing. But we sort of arrived at the same conclusions. So I should add no, that this lesson is actually part of the second set of modules for this quarter, which is actually much better written than the first set. So medyo okay silang basahin. So if you have time to do that, please do so. So thank you very much and I'll see you sa next video lesson natin.